All right, let's look at the numbers 21 through 25 on the MCA packet. Number 21 asks us to solve for g in this equation. And a couple things that I noticed right away, there's more than one variable. In fact, there are three different ones, and there are two g's. And since we want to solve for g, the first thing we're going to want to do is try to get those g terms together. So what I'm going to do is add 5g to both sides. That will cancel out with that negative 5g. So now I'm left with 6h over here equals 7k, and then 6g plus 5g is 11g. Alright, now that we brought the g terms together, we want to solve for g, so we want to isolate g, get g all by itself. Meaning I want to push anything over to the other side that I can. So I'm going to subtract 7k on both sides, which will get rid of this. And now I'd be left with 11g equals 6h minus 7k. Cannot combine those two since h and k are different variables. And now we're just left with one step. G is being times by 11, so I'll have to divide both sides by 11 in order to solve for g. And now we're left with g equals 6h minus 7k over 11. So we'll be looking at B for our final answer there. Alright. I don't recommend plugging that answer back in and seeing if it works out, but you actually can do that. Just make sure you follow your steps carefully there. Maybe try that one twice, or maybe try solving it a different way and see if you get the same answer. Alright, number 22, convert the following equation into standard form. Okay, standard form is our ax plus by equals c, where a, b, and c are all integers. Okay, and typically we don't like this a to be negative. We're going to want that to be positive. That's usually how it works. Some standard forms allow it. Looks like this one is positive for each answer. We probably won't have to worry about it, but we'll find out. Alright, so the first thing we need to do is get x and y on the same side, and then we don't want any fractions for a, b, and c. They're just integers. We'll take care of that. So the first thing I would do is we have a negative 3/4 x. I would add 3/4 x to both sides. Oh, by the way, your ax plus by equals c formula is on your MCA formula sheet. Alright, so we are left with 3/4 x. This is a positive y, so we'll say plus y equals, these canceled, we're left with 2. Alright, so we're only left with one other thing to do. We don't want any fractions for a, b, and c. Standard form only wants integers for those numbers. So in order to get rid of this fraction, I'm going to multiply everything through by 4. And the reason I'm going to do that is because the 4 will cancel out with the division by 4, or the 4 that's in the denominator here. You can try it if you want to. 4 over 1, if I did 4 times 3, I'd get 12. And then if I did 1 times 4, I'd get 4. Well, what's 12 divided by 4? I get 3. So these just cancel, and you're left with that top number anyway. So that's why I'm doing that. Very simple way to get rid of fractions. So we'd be left with 3x. Now I do have to take this 4 times this y as well. So 4y equals, and of course I got to take this times 4 as well to keep both sides equal. So 3x plus 4y equals 8. Looks like we're looking at D for the final answer on that one. Okay, so that's how we do that. Moving on. Number 23. Okay, a little word problem here. Sophie sells hot cocoa for $1.25. So I'm going to put an H there for hot cocoa, and coffee for $1. Okay. Which inequality shows H, the number of hot cocos, and C, the number of coffees she must sell to make over $50? Alright, you can eliminate two of these right away because H and $1.25, or hot cocoa costs $1.25, H has to go with the 125. You'll notice that in C and D that it's matched up with the wrong variable. So we can eliminate those two right away. And then the only other thing we need to figure out is, okay, well, if she's selling both of those at the same time at the price that they're there for, that would mean, okay, $1.25 times H, or however many hot cocos there are, plus $1 times C will be the total amount that is sold. So all we need to figure out here is which one of these represents making more than $50. She wants to make over $50. Well, we would want this to be greater than $50. So B is the correct statement there, okay? Because we want that to be over $50, okay? So that's how we would set that one up. Okay. Moving on to our last two here. Solve the following inequality for C. All right, so we have an inequality. We want to solve for C. So here's what I would do. A couple different ways to do this, but I would add 3C to both sides. Since I've got a C term on both sides, we're left with 9. And then 9C minus 9 on that side after we combine 6C and 3C. All right. And now to solve for C completely, we get rid of everything else that's over there with it. We'd be left with 9C is less than 18, and then we would divide by 9, and we would get C is less than 2. Looking at D. All right, and lastly, looking at number 25, we've got, they give us one solution to this absolute value equality or equation. One solution is 5, what is the other solution? Two different ways you can do this. You can set up your second case. You can actually take this and say, well, I know that that has to equal positive 8. That's the solution they solve for. But 4x minus 12 can also equal negative 8. And you can solve this equation, it'll get you there right away. You would just add 12 to both sides, and you'd be left with 4x equals 4. Well, 4 times 1 has to give you 4. The other way that you could do that is actually try plugging in these numbers. So if I plug in 1 for x, 4 times 1 is 4, and then 4 minus 12 is negative 8. Oops, sorry, but in an absolute value it comes out to positive 8. So that's the other way that you can do that. You can just plug them in and see which one works out, okay? So C for